Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience and for tuning back in. This week on the show, I meet up with Chuck Ridgeway of Horner Automation, a company we've been covering a lot on the morning show. And he takes us through their product line of PLC HMIs, distributed I/O, and other products, and also talks about a lot of the applications they're used in. Very interesting stuff. But before we get to that, I do want to thank our sponsor who made this episode possible, theautomationschool.com. They covered all our costs to produce this episode. And so if you know anybody looking for PLC, HMI, or SCADA training, please mention theautomationschool.com to them. And with that, let's learn all about Horner Automation with Chuck Ridgeway in this episode of the Automation Podcast. I am very glad to have Chuck from Horner Automation on today to tell us all about his products. We've been covering Horner and their weekly live streams and webinars on the morning show, and it's made me very curious about their product line because it seems like they do some pretty cool stuff. So I'm really glad to have you on, Chuck. And before I turn it over to you, before you jump into bringing us up to speed on your product line, could you first introduce yourself to our audience?
Sure. Thanks, Shawn. And I appreciate you for having me on today. So my name's Chuck Ridgeway. I'm the Automation Technology Manager at Horner Automation. We are a manufacturer of automation products in Indianapolis, Indiana. Now, we're not a systems integrator, but we're a manufacturer. And what we're known for are manufacturing all-in-one controllers. So components that have the functionality of a PLC and an HMI built into the same component. Now, we make a lot of our products here in Indianapolis, Indiana, and we're really popular among OEM machine builders. Now, for me personally, I started my career in the automotive industry up in Michigan. And then in the late 80s, I got my first automation job with Square D, back when they actually had their own PLC division before they were purchased by Schneider. And then a couple years after that, I moved to Indianapolis and started working with Phil Horner and the folks at Horner Automation. Now, I started as an applications engineer, so I am technical. I have an electrical engineering background. A lot of my career was spent as the product manager at Horner. But really, for the last 3 years, I've kind of been I guess you could say, the brand ambassador. We're tired of being the best kept secret in automation. And so I've been doing things like guesting on great podcasts like yours. And as you mentioned, we do a weekly live stream, and we've been doing that for the past 3 years. So that, plus a bunch of other great video content developed by our marketing team, you'll find that on our YouTube channel. And between that, as well as going to trade shows and talking to folks like you and visiting customers, I'm just having a ton of fun.
Nice.
So today, awesome. So today, what I'd like to do is a couple things. One is, of course, I want to tell folks about Horner Automation, who we are and what we're all about. I want to talk a little bit in general about all-in-one controllers, because I found that a lot of PLC users aren't as familiar with all-in-one controllers as I otherwise would have thought. Of course, I'll talk specifically about the types of products that we have at Horner, the types of all-in-one controllers we have, and then I'll spend some time talking applications. So what are some of the applications where maybe an all-in-one controller might even be a better fit than a PLC? So hopefully for your audience that's kind of zeroed in on, one approach to solving automation and maybe one or two vendors, hopefully it'll give them a little bit of food for thought. So shall I go ahead and jump right in?
Yes, please do.
All right, let's do that. Okay, so who is Horner Automation? So as I mentioned before, we're a U.S. manufacturer and designer of automation products, specifically all-in-one controllers, a PLC with a built-in HMI, and we offer free software as part of our business model. Our brand name is OCS, and that stands for Operator Control Station. So that's what we call our all-in-one controllers. Now, a lot of our customers put their name on the front of our products or their logo, which kind of tends to keep us in the background, which actually is great in a lot of ways because our customers love it. They are front and center on their machine like they should be, but it also kind of helps us, it makes it a little more challenging to get our name out there when we're in the background. So other things you should know about us, as I mentioned, we're based in Indianapolis, Indiana, but we do have a worldwide footprint. For example, our European headquarters are in Cork, Ireland, and we have customers all over the globe. Now, we are a family-owned business. Now, we're not tiny, but we're not a giant corporation like a lot of our competitors are. And a lot of our products are manufactured here in Indianapolis in the US. We design our own hardware, we design our own software, but we do some partnering where it makes sense, like a lot of automation companies do. Nobody makes everything, of course.
Hey guys, just want to break in here quickly to thank our sponsor, theautomationschool.com. They actually made this episode possible by covering our expenses to produce this episode. So if you know anybody who's looking for a PLC, HMI, or SCADA training, please mention theautomationschool.com to them. And with that, let's get back to the show.
Now, what our customers tend to like about us, first of all, as I mentioned before, we're very popular with OEM machine builders. So we do our best to provide excellent OEM support and to develop really close OEM to supplier relationships. Now, one area that's really helped both our OEMs and ourselves is that we really have striven, is that a word? We really strive to have strong inventory and short lead time. So during this whole supply chain crisis, while a lot of our competitors were really struggling to maintain, shipments and extended their lead times out to very long number of months or even more than a year in some cases, our owners during the crisis or during COVID, for instance, we kept buying components. We didn't cancel any orders. We took an optimistic view. We said, we're confident that things are going to come back quickly after the crisis abates a bit. And sure enough, it did. And so our customers have enjoyed short lead times and strong inventory from us through the crisis. So that's been terrific. We've done a good job of that. Great job by our operations team. Now, another thing our customers like about us is that our business model is free software, free firmware updates, free technical support. So there are no charges for any of those sorts of things. Also, another thing that we do pretty well, and our customers tell us they like this, is that regardless of whether you use one of our lower end products or our higher end products, you can reuse a lot of the code and a lot of the system design elements from one project to the other, up and down the product line. So that's a big deal. And as a matter of fact, even though it's been greatly enhanced over the years, we still have the same software basis for the very first Horner product that we produced back in the late 90s, the first all-in-one controller at least. So if you have one of our all-in-one controllers from 1998, one of the very first models, and a lot of them are still in service, you could take the program from that controller and you could use that program as kind of a starting point for a newer application if it was reusable from a logic standpoint, for instance. So that, decades-long upward compatibility, we've really work to maintain that as best as possible. Another thing that our customers tell us that they like about us and our products is that when you take a look at the functionality of our all-in-one controllers and the physical size of them, you can't get a whole lot more functionality per square inch or per square millimeter, in traditional components because everything is integrated. So as an example, if you're manufacturing, let's say, desktop assembly machines for a medical device or something, you've got a machine that's got to do a lot of things just like any other machine, like one that's assembling automobiles, for instance, but you have your machine needs to fit on a tabletop. So if you use one of our all-in-one controllers, you aren't giving up any functionality per se, but you're getting it in a lot smaller footprint. So those are some things that our customers tell us that they like about working with us. Now, in terms of the markets and the industries that we're in, again, we're really popular with OEM machine builders, but in all kinds of different industries: oil and gas, water, wastewater, mobile equipment, building automation, agriculture, food and beverage, you name it. And we're also very popular with end user applications as well. So even though that's a much smaller portion of our sales, we have some major manufacturers that a lot of folks have heard about in the mobile industry and in a lot of other industries, automotive industry, for instance, using our products very successfully. Agriculture is another big end user market for us. So anyway, I won't do any name dropping today, but we're being used by a lot of major manufacturers out there. Now I want to get to the part of my presentation or the part of my discussion where I talk about, let's compare a PLC versus an all-in-one controller. Because again, I've discovered that not as many people who are PLC users are necessarily familiar with all-in-one controllers. So I want to kind of compare and contrast those for the benefit of your audience. So let's start with the traditional approach. Of course, the PLC. We're all familiar with PLCs if we're in the automation industry. They're everywhere. They're the heart of the machine. And of course, PLCs are used with a bunch of different separate components in almost every control system out there. You know, when I started my career, you know, I'm getting older now. When I started my career back in the 80s, not a lot of machines actually had a operator interface on them. I mean, they would have push buttons and pilot lights and meters, but operator interfaces were pretty rare. These days, even the smallest of machines has an operator interface or an HMI on it, okay? So in addition to the PLC and the HMI, we've got remote I/O, we've got drives that we're interfacing with, we've got SCADA systems and other, you know, factory automation systems or information systems. All those components are everywhere, right? With a lot of the new equipment that's out there, a lot of the equipment that's out there. And that's really the traditional approach. Everything is a separate component. Now, with all-in-one controllers, they're the same but different. How are they the same? Well, they're still doing the basic job of control for the machine. They're still programmed using ladder logic or IEC 1131 programming language. It's the traditional way that you program a PLC. They still work like a PLC. They have a logic scan. They scan from left to right, top to bottom. So there's a lot of similarities in an all-in-one versus a PLC. The biggest difference is that when you buy an all-in-one, you're getting more than, let's say, a logic CPU and some built-in I/O and maybe some networking. You're getting all those components every time. So for instance, when you purchase a Horner all-in-one controller, you're guaranteed that you're going to have a logic controller, a built-in HMI of, you know, a variety of different sizes. You're going to have some amount of built-in I/O, a bunch of choices on that. You're going to have a lot of communications capability, whether it's a field bus or whether it's industrial Ethernet, or it's both really. And then a whole bunch of other things like removable media for micro SD slots for doing all kinds of functions like data logging and you name it. So really the thing with an all-in-one controller, it's really not that much different. There's just a lot more included in the basic component than what you will find with your PLC, where some PLCs are very integrated, like a micro PLC, for instance. Some PLCs are very much more modular. And one thing that a lot of people are surprised by is the fact that all-in-one controllers have really been around for 25 years now. Our first all-in-one controller was 1998. And this is 2023 and 2024. So, 25, 26 years since those products have been in existence. Now, there, of course, are advantages with PLCs and advantages with all-in-one controllers. So I'm just going to go through a few of those here. PLCs have the advantage, one big advantage, is that there is familiarity, right? We're all familiar with PLCs. We're familiar with the major PLC manufacturers that have been out there for a long time and that have a big brand name. They're manufactured by big companies. So a lot of people think of that as being safe, right? Okay, this big company's manufacturing it. That's a safe choice. I'm not going to get in trouble for using this big brand PLC. And often another advantage PLCs have is they're often specified by big automation end users. So maybe a big food and beverage or a big paper company will specify, hey, we only use brand X PLCs in our system, so we're going to specify those for our machines. So there's definitely some advantages to PLCs. But there's also advantages to all-in-ones. Generally, on a system basis, they're usually less expensive because when you add up all the separate components that you would buy in your traditional control system, an all-in-one controller can give you those same components at a much less cost in a far less large footprint, so a smaller footprint. They take up less space, which also can be saving in terms of cost, right? Because the control panel's smaller, those sorts of things. Also, one thing people don't think about is that especially for OEM machine builders who are shipping machines all over the place, you've got one program to manage with an all-in-one controller. You know, the same application file handles your logic, handles all your screens, handles all your network configuration. So you literally have one file to maintain, where a traditional PLC and an HMI, you're going to have a minimum of two, right? And that works with firmware too. One firmware upgrade to manage versus two or more firmware upgrades to manage. So that is definitely something to consider as well as an advantage to all-in-ones. And then from a business model standpoint, typically all-in-one manufacturers have a little different business model than the major PLC manufacturers do. And let me kind of go into that a little bit next.
Hey everybody, just want to break in here with a message from our sponsor, theautomationschool.com. Right now they have a special going on where if you buy their current level 1 and 2 course on, say, control logics or compact logics or micro logics or micro 800 and so on, you will get the new 2024 edition completely free of charge. And you can see I got all this equipment on the table here. This is new equipment we've recently purchased at theautomationschool.com, well, new used equipment, to actually add to the courses. So you may also see some Slick 500 and PLC 5 items. Well, that's because we're also have a pre-order on those two courses as well. Now, I'm excited about going through and testing all these. I've tested about half of it. Most of the vendors we use never send us anything that doesn't work. But in any case, you do have to go through it and test it all just to be sure, right? And once that's done, then we'll be clearing off the workbench and filming new episodes. And if you do buy the current level 1 and 2 course, or you pre-order those legacy courses, then you will get every lessons as it comes out in the new 2024 editions. You'll see them. They're called the Ultimate courses. So with that said, if you know anybody looking for PLC, HMI, or SCADA training, please mention theautomationschool.com to them. And with that, let's get back to this show.
So the typical PLC business model for the large automation manufacturers, and these are good companies, I'm not knocking them, but this is their business model. Typically, they're charging for software, usually through an annual subscription. They're typically charging for support, usually through some sort of support contract. And because they're bigger companies, they're typically taking a very conservative approach to supply chain, and therefore, anytime there's a disruption, generally their lead times can get pretty long. Also, because they are large companies, they have a prioritization of large customers, and that's not unique to large companies for sure. And there's nothing wrong with having a prioritization for large customers unless you're not a large customer. Then it can be rough when you need to get product and you're not high up on the list when there's a supply chain disruption. So again, this is some of the things that you can run into if you're not a huge customer and you're looking at, the major PLC manufacturers, for instance. Now, the Horner business model, and I can't speak for all the all-in-one controller manufacturers, but the Horner business model is a little bit different. And part of that is because we are a smaller company and we have a little bit of a different culture and some different requirements. So as I mentioned before, all of our software is free. We don't charge for technical support. We don't charge, and it doesn't matter how old your product is. If you call in with a support question on a 10-year-old Horner product, we're not going to say, sorry, that product's out of warranty. You'll have to call back some other time. We're going to take care of you as best we can. And because we're smaller, we also have taken a very aggressive approach to supply chain and keeping the lead times and the inventory levels at industry type leading type levels. And I mentioned that before. And then again, because we are small to medium-sized automation users tend to be more important to us. I mean, that's just the realities of the math, right? We're not as big as some of the big PLC guys, so smaller automation users are more important to us just as a matter of scale. Okay, so that's just some comparisons between all-in-one controllers and PLC. And really, if you listened, you heard that there wasn't a lot of difference in the hardware per se. Yes, you have more components built into an all-in-one, but they're still programmed just like a PLC. They still, run just like a PLC with a logic scan and that sort of thing. They're still programmed with automation software. There's a lot of similarities.
Hey, can I ask a question? I hate to
Sure,
interrupt.
fire right in.
Yeah, so I think, and for the audio audience, I'll throw this out there. So with an all-in-one HMI PLC, right, all-in-one control system, typically everything's mounted on the door of the enclosure because you want to be able to access your HMI, your touchscreen. And so I guess I would say one difference is how much local I/O you can have before you have to go across a network to some remote I/O. Now, I could be wrong about that because we haven't actually looked at your hardware products, but I'm kind of teeing that up because you see in the pictures early on, you see an HMI with a bunch of I/O and field buses and industrial Ethernet. And so maybe that's one difference.
That's a great point, Shawn. Thanks for bringing that up. Yeah, sure, absolutely. So when your I/O count goes above a certain point, right, then obviously you do have some more differences there. So with our products, and I'll kind of cover this when I go through the built-in I/O component. With our products, once you get over, I don't know, let's say 40 I/O points, you're pretty much mandated to have your I/O, in the back plate through a remote I/O connection. So that's absolutely true. And it's also true that a lot of our customers prefer to have maybe all or a majority of the I/O still in the backplate just because they prefer that. They might have a few I/O points. Some customers might have a few I/O points wired directly on the door, for things like operators, push buttons and stuff.
Perfect.
And then the rest of their I/O, they may prefer to have it in the backplate.
Okay.
So that's an excellent point on your behalf there.
Thank you.
Excellent. Okay. So the next thing I wanted to talk about was some of the specifics about the Horner's all-in-one controller. So I've talked so far kind of in general, specifics about the Horner company type characteristics and kind of our business models and things. But now I'll talk more specifics about the Horner all-in-one controllers. Okay. So the first product line, the entry-level product line from Horner, is something we call a micro OCS. And we named it a micro OCS because it's really analogous to a micro PLC. Everybody kind of understands what a micro PLC is. And so we said, well, this is our entry-level product. It's great for, typical simple applications. So let's call it a micro OCS. And with the micro OCS family, we have 4 different screen sizes. So it ranges from just a little 2-inch screen all the way up to a 10-inch touchscreen. And there's a 7-inch and a 4-inch as well, with the 7-inch and the 4-inch being the 2 most popular, actually. And then in terms of built-in I/O, one thing about the micro OCS is that you've got 2 different options when it comes to built-in I/O. You've got 4 different screen options, but you've got 2 different I/O options. So we have a Model R, which uses relays for outputs, that has a total of 26 I/O points, 12 digital in, 6 relay out, a couple of high-speed solid-state signals, 4 analog in, and 2 analog out. And the analogs are 4 to 20 milliamps for both input and for output, and they're 12 bits in resolution. And then we have a Model A, which is identical in every way, but instead of 6 relays and 2 solid states, it has 12 solid states on the output side. Now, I know the first thing you're probably thinking is, wow, that's a lot of I/O for a pretty small product. And that's true. What we decided to do with the micro OCS family was, what you'll find with the micro PLCs is a typical PLC manufacturer might have half a dozen different options that only vary by the I/O complement. So what we decided to do instead was just have 2 options and price it so that even if a customer is only using a fraction of the I/O, it's still cost effective. So that was really kind of the reasoning behind just having the 2 different I/O options for the micro OCS family. Now, in addition to the built-in I/O, from a logic standpoint, you can handle programs as large as 512K, that's just for logic, and we can support up to 7,000 variables. Now, most applications where used by the micro OCS where the micro OCS is used is far less than that, but that's the capacity. And then from a process control standpoint, we do support floating point math, and we can support up to 4 PID loops. Now, from a programming standpoint, it's like all of our products. You can program it in traditional American-style ladder logic, or you can use full IEC 1131, all 4 of the most popular languages. We also support the instruction list, but that's kind of dropped off the list of the IEC languages from a priority standpoint. So you can still program them, again, like a PLC, whether it's just a traditional ladder logic-based PLC, or whether it is a IEC-based unit. And then from a communication standpoint.
Hey guys, I just want to jump in here quickly. Did you know I have another show? It's called The Automation Morning Show. And a couple times a week, I look at over 200 automation vendors, see what's new and happening, and then I share it with you on the mornings, typically around 7:30 in the morning. Although you can watch it after the fact or listen to it after the fact. The good news is I publish The Automation Morning Show to the same destinations that you get the Automation Podcast at. So whether you like YouTube or iTunes or theautomationblog.com, you can get the Automation Morning Show there just like you get the Automation Podcast. So if you get a minute, please check out my new show, the Automation Morning Show New. It's actually a year old. We're on episode 156, 157 now. So if you get a chance to check it out. And with that, let's jump back into this show.
And I'll back up one slide for you viewers here. From a communication standpoint, it's got a relatively large number of protocols built in, at least the most popular one. From an Ethernet standpoint, it supports Ethernet IP as an I/O device, not as a scanner. It supports Modbus TCP as either a client or a server. It also has BACnet IP available for it, and BACnet is building automation and control. It's become kind of the de facto standard for building automation. And then from a field bus standpoint, it supports our own proprietary I/O expansion network called C-SCAN, which we first developed back in the 20 years ago, or 25 years ago now, for the U.S. Post Office for some high-speed material handling applications. We use that for our I/O expansion. And then we also support CAN Open. So for those folks looking to interface with motion control or with standardized sensors or something on a field bus, we support CAN Open as well. So we do a lot of communications with the micro OCS. And then one other thing I'll mention, and that is all of our products, including the micro OCS, support micro SD memory slots. So they have a micro SD memory slot, so you can do maintenance of the equipment from micro SD. You can do data logging. You can do all kinds of things from that memory card. And you're not going to run out of memory. It can support at least 64 gigabyte cards if that's what you need to use. So that's the micro OCS kind of from a behind the hood standpoint. And then in terms of the applications where this product line has done well and been used, there's just a ton of them. So pump control is a very popular one, all different types of pumps, all different type of control applications. Environmental control, building automation, which I think I mentioned before with BACnet support. Fan control, level measurement, irrigation, metering, mixing, dispensing machines, all over the place. The micro OCS has been used. And generally what we will say, it's our entry-level product, but when you compare it against the types of entry-level products that it competes with, it has a lot of capability. So that's the micro OCS series. That's, as I said, that's our entry-level series. Now, the next series I'm going to talk about is called our XL Prime series. And this is in some ways, this is our newest series. This is our high-end series today. And it is based on a product that we've had in the field for some time, but this is a new version of that product with upgraded microprocessor and a updated memory structure. So the XL series, which I'll talk about in a minute, has been around for several years now, and it's got the most installed base in the field. What we did with the XL Prime is we modernized the internal electronics to make sure it's manufacturable for years to come, and also to eliminate batteries as much as possible. So one of the banes of existence in the PLC world and the all-in-one controller world are batteries, because at some point a battery is going to need to be replaced, or it's going to wear out, or whatever the case may be. So with the XL Prime series, what we have done is eliminated all the batteries except for the real-time clock battery. That's the only one that we have in there now, just a small cell for the real-time clock. All other batteries have been eliminated. So that means that all your program variables, all your settings, all those sorts of things that normally a PLC would use battery-backed RAM for, we now use FRAM or MRAM for. These are newer memory components, memory chips that don't require power to maintain, their memory, again, through a power cycle. So because of those modern components, we've been able to eliminate all the batteries in this product, except for the one in the calendar clock. Now, this particular product's a little bit higher end in terms of its capacity. So it's got a faster scan rate than the micro OCS. It can handle larger programs, so programs up to 2 megabytes in terms of the logic portion, and it can handle up to 70,000 variables. So those are some pretty large programs that can be supported, and some pretty good sized machines that can be supported with the XL Prime series. And it's available with 4 different screen sizes, so 3.5, 4.3, actually 5 different screen sizes, 3.5, 4.3, 5.7, 7, and 10. It's kind of unique at Horner that we've continued to support the 5.7-inch size and the 10.4-inch size. Those are sizes that a lot of manufacturers kind of dumped years ago. But we continue to support them mainly because we have OEM customers that don't like to change unless they're absolutely forced to. So we try and not be the reason they have to change as much as we can. And then another aspect of the XL Prime series that I want to talk about is it builds upon those same protocols that are available for the micro series. We talked Ethernet IP and Modbus TCP and BACnet for that series. Well, we support all those and additional ones. So, and we still support CAN Open, for instance, but we've added things like MQTT Sparkplug. So for those folks who are really interested in IoT, industrial IoT specifically, MQTT Sparkplug is kind of one of the most popular ways of pushing data to the cloud or to a server for an IIoT type approach. And that's supported by the XL Prime series. And then in addition to that, we also support a protocol that may not seem that popular, but it's popular with a lot of our customers, and that is J1939. So J1939 is the protocol that exists in every automobile, in every piece of off-road equipment, in every piece of automation equipment that has like a diesel engine on it. So some sort of portable generator or compressor, they're going to have an engine on there, and they're going to have an engine control module, which means they're going to have J1939. So that's one of the reasons why we're doing so well in the mobile market or in interfacing with mobile equipment, with the big, agricultural and off-road type vendors, is because we do support that protocol. So they can connect our equipment to an engine control system, and instead of having to have parallel instrumentation, they can monitor things like throttle position and temperatures and pressures and things that are just naturally reported over that network. We can support it on our controllers, unlike a typical PLC would. So that's the XL Prime series from a communications and a logic standpoint and a screen standpoint. Now, on the I/O side, before we dive into the I/O, let's talk about the series that the XL Prime series was based on, and that is the XL series. So for those of you who don't have, the advantage of watching and having visuals, there's a lot of similarity in the look and the feel between the XL Prime and the XL series. They look almost identical from the outside. In a lot of ways, they are. That's because we designed the XL Prime to be a logical long-term replacement for the XL series. So it looks the same from the outside, and all the improvements were on the inside. But in terms of the XL series, it doesn't mean it's immediately being discontinued, because we're not doing that. Again, OEMs are our customers, and we try and let them redesign their machines on their schedule as much as possible. But rest assured, the XL series shares all the same characteristics as the XL Prime series, with the exception that it has a previous generation processor, and it does use more internal batteries for maintaining things like variable memory through power cycles. So much more battery usage on the XL series. Yes, sir.
I just wanted to chime in here for the audio audience. This may bring a smile to your face, or I think, but the XL series and the XL Prime series also list DeviceNet as a supported network. Is that true? I see it on the slide.
It is true, actually. We do, and I'll be the first to mention, we do not have a lot of customers using it still after all these years. But when you support OEMs, you're hesitant to take anything out of your product, even if it isn't used a lot. So yeah, so we support DeviceNet as one of the protocols that's available in the XL series and the XL Prime, as you'd expect, as a DeviceNet master. Right. So if you had a sensor or something on DeviceNet that you wanted to interface with, we still support it.
Well, that's and I hate to bring it up because I know for a lot of people it's a swear word, but I was in with when that came out from Rockwell, and
sure,
it just brings back a lot of fond memories of the whole the beginnings of DeviceNet. But in any case, let me turn it back to you.
All right. Yeah, I mean, CAN is a very viable network, right? But what you put on top of the CAN chip, the protocol details you put on top of the CAN chip, makes a big difference in terms of how it operates. What were the goals for the protocol? What were you trying to achieve? So there's a big difference in the protocols in terms of what they're trying to achieve, and those were the heady days of development for a lot of those networks. Okay, so one of the ways that the XL series and the XL Prime series differ from the micro OCS is the way they handle built-in I/O. So if you remember when I talked about the micro OCS, you had two options, relay-based or not relay-based, 26 points if it's relay, 30 points if it's not. With the XL series and the XL Prime series, we have 6 different I/O options that you can order from the factory, not just 2. And one of them is no I/O built in at all. So we have some customers that they don't want any I/O on the door whatsoever, no cabling that's I/O cabling going through the hinge or going, that direction. So they have the option of ordering XL series all-in-one controllers where all the I/O is remote. Okay, either in the same enclosure that the OCS is mounted, or maybe located, hundreds of meters away, depending on their application. But the other options that are available range anywhere from 22 I/O points up to, say, 40 I/O points. And again, most applications, they're using a portion of what's available as built-in I/O. A couple of the models I will highlight. One of the more popular models is the 22-point model. It has 12 DC ins, 6 relay outs, and 4 analog ins. That one's very popular. And one of the reasons it's really popular is it doesn't cost a lot more than just getting no I/O at all, right? And so those customers discover that they can take a few of those I/O points and use it for on-the-door pilot lights, or maybe a little bit of high-speed counting, or just they can find the utility there for a few push buttons or gauges or whatever they need. And it just saves them from actually having to run wiring from the back plate up to the door to wire those operators and things. And then another one I'll highlight is our Model 6, as we call it, which is the most analog heavy. So that one has 6 universal analog in and 4 universal analog out, where they're all at least 16 bits in resolution on the input side, thermocouple RTD, 4 to 20 milliamp or 0 to 10 volts.
I got to ask something, and
Sure.
you're probably going to show it in a future slide, so I apologize. But I keep going back to this question. Is that I/O part of the OCS, is it removable and replaceable from the main screen, or is it kind of all built in together?
Yeah, no, it's all built in together. That's a great question. So yeah, that's everything I've talked about so far. You'd order from the factory. Okay, so it's going to come this way from the factory. A little later on, I'm going to talk about the remote I/O options that we have, but those are more traditional mount-on DIN rail type I/O options there.
Got it.
Okay, great question. Thanks again. Okay, so those are, again, some of the highlights of the I/O options you can order when you specify the specific model of OCS controller that you're looking for. Okay, so from an application standpoint, the micro series we talked about, that's the kind of what we call the best solution for simple applications. Well, because of the added horsepower and added capabilities of the XL and XL Prime, you will find them being used in some more rugged and some more robust, and also just some more complex applications. Remember, you've got 4 times the program memory, you've got 10 times the variable memory, and a much faster scan rate to be able to handle that added load, if you will, of additional I/O and additional logic. So the types of applications where these products have done well: environmental control, water remediation. A lot of skid-mounted control systems in the water remediation industry are based around OCS. Crop monitoring and drying, for agricultural applications, big remote irrigation systems in a lot of different agricultural areas, including cranberries. We're very big in cranberries. Mobile equipment, partly because of the J1939 capability I talked about earlier. We're doing business with a lot of the mobile equipment vendors, and they're using us as a supplier a lot of times in their factories as they're manufacturing their equipment. Their front-end loaders and those sorts of things, and their tractors. They're using us in their factory to kind of test out their designs in their qualifications department. Also in the automotive area, one of the areas we're very popular in is similar test cells, where they're testing transmissions and engines together, and they need to exercise those components together and simulate, 100,000 miles of usage or something. They use our products to control all the test cell parameters for, starting and stopping and speeding up the throttle and slowing down the throttle and all those sorts of things. And that's all possible, not only because we're a PLC-like device, but also because we support J1939. Other applications: chemical metering, offshore pump control. We're were installed on several offshore platforms doing mud pump control. That's kind of the specifics on that guy. High-speed packaging equipment, compressor control for facilities, giant compressors that are used to provide compressed air in facilities, and a lot in shipboard automation. Not necessarily much for controlling the ship per se in the engine room, but for systems that are needed on big cruise ships or on tugboats or whatever the case may be. On cruise ships, it can be things like, water systems and waste systems and those sorts of things, and monitoring systems. So lots of applications for that as well. So what we find with the XL and the XL Prime is there's just a lot of kind of more advanced applications and some really unique industries in some cases that are using this particular product. Okay, now we're going to get to some of the other I/O options, and these would be remote I/O options that are available to interface with the OCS All-in-one controller. So in some applications, again, customers need I/O either more than what's available built in, or maybe they want to locate the I/O away from where the screen is mounted, right? Maybe it's 50 feet away or 500 feet away or something. So that's where we have a whole variety of options for remote I/O and expansion I/O. And then the product family I want to highlight for that today is something we call OCS I/O. And it's for those of you who don't have the visuals, it's a traditional I/O system where you have an I/O base that interfaces with RJ45 connectors. And then connected to that base, you can have as many as 7 additional modular I/O modules. And then you could have as many as 8 of those bases, actually maybe as many as 16 of those bases. But anyway, at least 8 of those bases with 8 modules each. So that can add up to a pretty large system. And effectively, the wiring is just uses RJ45 cabling, and it's more or less daisy chained is the approach. So, and there's lots of options for the different types of I/O that you would have. The typical things, right? DC in, DC out, relays. We even support AC inputs with this family. We hadn't designed an AC input card in years, and we got enough requests that we said, all right, we'll do it. So we've got an AC input card available for this. We have a very unique analog card. So it's a 4-channel universal analog input card. So each channel can be configured independently, and it can be 4 to 20 milliamp, 0 to 10 volt, one of a variety of different thermocouple types, JKT, NRS, those sorts of things, and a couple different RTD types as well. So lots of flexibility there. And you can do 1 RTD, 1 thermocouple, and 2 milliamp if that's what you want to do, right? And then we've got other options, including, thermistors and high-speed counters on the way. So we do have remote I/O options. It's a Horner-designed product. We did use off-the-shelf Phoenix contact terminal blocks and plastic. So the plastic we didn't design, but all the electronics, all the firmware, all the way the system goes together, everything but the mechanical package was designed at Horner and built in Indianapolis currently.
Now, let me ask you a question. That first module with the 2 RJ45 jacks, right?
Yeah.
Does that have some built-in I/O on it as well?
It does. And, I forgot to talk about that. And you did a magnificent job in stopping me so I could do that. So on a typical remote I/O base, right, or expansion I/O base, usually the base is just for maybe power and to connect the PLC. Typically, that's it, right? What we're doing that's a little different with this particular base for OCS I/O is we have 6 flexible I/O points built into it. And those, for instance, 2 of the I/O points can either be DC inputs, either 5, 12, or 24 volts. You could even set your own threshold if you want. Or you could decide to configure those as a 0 to 10 volt input or a 4 to 20 milliamp input, 12-bit resolution. So that gives you a lot of flexibility for those 2 points. Then we have another point that is a universal analog in that's 16 bits. So if you had a temperature sensor or a high resolution pressure sensor that you needed to interface with, you can use that 16-bit input point and configure it for thermocouple RTD or 4 to 20 milliamp or 0 to 10 volt. And then we also have a couple of general purpose. We have an analog output, 4 to 20 milliamp or 0 to 10 volt. And we also have a couple of general purpose 2 amp solid state outputs as well. So with some of our customers, especially the ones that are using the micro OCS, they might just be adding that one module to their system to get that high resolution analog input or that extra analog output that they need, or some combination thereof, without having to add any additional I/O modules to the stack, if you will.
Now the stack, I want to ask you about that. Do they slide
Sure.
together? Do they snap together?
Yeah, they slide together.
Okay, they
slide
slice
together.
I/O. Okay.
Yeah, so you've got a backplane component. This was designed, the backplane component was designed by Phoenix. It snaps on the DIN rail.
Okay.
So you snap your backplane components on first. And if you're 2 wide, you have 2. If you're 4 wide, you have 4. Snap those on first. And then the modules snap on from the front, top to bottom.
Okay.
But you still have the capability of removing a unit from the middle if you need to. So let's say in the future you've got a stack of 4 and the third module needs to be replaced. Well, you don't have to slide the stack apart to get that third module out. You can remove that without having to disassemble the stack.
Makes sense. Okay.
Yep. All right, very good. So that's the primary I/O system that we're offering these days. Now we've got several other systems with different characteristics that are some are manufactured by us and some are partner products, but this is the one I wanted to highlight today. That's the newest, and that's OCS I/O. A couple other things I wanted to highlight as I'm kind of doing the Horner part of the presentation here. All of our controllers have, as long as they have an Ethernet port, and every controller we sell but one has an Ethernet port, have the capability of doing remote monitoring and control. So you can do that with no problem. Basically from a web browser, whether it's on a mobile device or on a computer, you can monitor and control what's happening on the controller if you set up that feature. So that feature we call WebMI, and it's one of the very few features that we actually charge for. So there is a one-time upgrade fee to upgrade your controller to support WebMI. If you do, then you can configure WebMI to either, one, replicate your screens exactly on a remote, mobile device or computer, or you could even decide that instead of doing that, I want to create completely new web pages, not restricted by the size of my screen, that are presenting machine data the way that the remote users want to see it. For instance, you may not, maybe your remote users are somebody in the preventive maintenance program or a quality control person or somebody in the production control group who wants to look at some machine information coming from that machine, but they aren't interested in seeing what the operator sees. They want to see different data. You can create web pages using our software that are basically published by the controller that those folks can look at, that is formatted the way that they want to see it. So that's what we call WebMI. And then the last thing I'll mention is that all of our products are programmed to use the same software package. It's our own software, so it's not something that we're buying from somebody. But using that software, you can configure your logic, you configure all your screens, you configure all your communications and everything else involved in the application. And that's all done from this free software package that we provide called Seascape. And again, you have your choice in logic languages. Do you want to use traditional American style logic? No problem. Do you want to use IEC languages? No problem. And even if you want to use the older fashioned register-based ladder logic that most PLC manufacturers have discontinued, we still support it. So that's also an option. So again, when you're a smaller manufacturer, smaller compared to the big guys, you learn to do your best not to force your customers to upgrade unless they really want to. So the next thing I wanted to talk about was I want to talk about some of the applications where maybe an all-in-one controller might be a better choice than a PLC in some cases because of all the different things that are built into an all-in-one. Remember, you've got a PLC, you've got an operator interface, you've got built-in I/O, you've got all kinds of different communication ports, you've got a memory card, you have IIoT protocols built in. So those are all things that you won't necessarily find in every PLC. So in some of these applications I'm going to highlight, you might not even be considering a PLC, or maybe this product will be able to do it better than a traditional PLC. So we're kind of, what's the visual on the screen here for those of you who aren't watching, we're talking about our product, our all-in-one control product, as a automation multi-tool. All the different, blades and things that are included in that Swiss Army knife to help solve a variety of different applications. So we're going to highlight a few of those here. Things like, well, instead of just going through the list, I'm just going to kind of one by one highlight these different applications. So one way you could use an all-in-one controller is as a PID controller or a temperature controller. Of course, there's plenty of dedicated PID controllers, PID loop controllers available on the market, but you could use an all-in-one controller as a PID loop controller. And depending on the model you select, you could do easily 4 PID loops from a single control, using a single controller, and you would have all that communications capability to nicely interface with the other automation components in your plant, over Ethernet IP or over Modbus TCP. And that's all built in and part of the standard functionality of the unit. You could also use our product as a protocol converter. Maybe you have several different devices from different manufacturers and different vintages, if you will, with some legacy stuff in there, and you need to be able to grab data from these products, sometimes exchanging data between them, and you can use our Horner OCS as a data concentrator or a data converter to maybe just gather data and concentrate it, or maybe exchange data between multiple devices. So because of all the different communications interfaces that we support, and the capabilities we have for data logging and those sorts of things, this can be a really interesting solution to, a problem of having a bunch of different equipment that doesn't normally talk nice to each other. High-speed data logging or even low-speed data logging is something that our all-in-one controllers do really, really well that you don't always find built into a standard PLC. So every OCS we sell has a micro SD slot that can support micro SD cards at least as big as 64 gigs. Of course, with our built-in I/O options, you can connect to just about any type of sensor or signal. And if you have certain parameters, process parameters you need to log, whether they be digital or analog in whatever form, you can just, in our software, you can just fill out a dialog box with, okay, these are the variables I want to monitor. Here's how long I want to monitor them. It will automatically log those in CSV format on the micro SD card on a periodic basis that you specify. And then you can deliver that data log file via an email if you want. You can make it extractable via FTP over Ethernet file transfer protocol, so the IT group can go grab it when they need it or whatever. But that's a really great functionality. Again, kind of the Swiss Army knife type solution that you won't find in a traditional PLC, not usually at least. Remote alarm annunciator. We all remember the alarm annunciators, even the old auto dialers, right? That well, not all of us remember, because some of the people with this in the audience are younger than I am. But auto dialers were devices that you would set up to monitor sensors or signals, and you'd connect them to a telephone line, and they would dial up somebody. You can still get them today, and they would dial up somebody and say, hey, you've got in a computer voice or something, would enunciate the fact that you've got an alarm problem. Well, the modern equivalent of that could be an alarm annunciator based around an all-in-one controller. Again, monitoring those signals, setting up alarm levels from within our software, displayed locally on the screen, of course, but also being able to be enunciated over email, through a text message. And then once that text message or email has been received remotely, you could log back into the equipment using, your web browser and WebMI if you've used that feature, and now get more information on what's happening at the site, that sort of thing. So again, that's another kind of Swiss Army knife type application where you can use one of our products. Machine monitoring is something that our products are used a lot for. As an example, there's a large automotive plant on the East Coast that is using, brand X PLCs everywhere in the plant, except for the machine monitoring, which they're using our stuff for. So basically what that company has done is they have strapped one of our all-in-one controllers mounted in a small enclosure to the side of a bunch of their machines. And that all-in-one controller is monitoring a few key signals, and it's got a stack light mounted to it. And it is connected to the plant network. And and the stack light is used to, at a glance, allow the electricians and/or maintenance people and/or material handling people to, at a glance, see what machines need attention in a particular work area where there might be 100 machines. And all this is done from an all-in-one controller. They could have done it from the PLCs running the machines, but it would have been a little more risky. It would have been a big undertaking, and this was just a better fit, they felt, to solve this application. And included in as an option is not only the stack light, of course, for enunciating issues, but you can also send emails and text messages as well, for those enunciations that you want to have happen electronically. And then think of that same exact application I just talked about, and now think of it as a remote monitor, where now we're not enunciating inside the plant, we're also enunciating outside the plant. So in that scenario, we've got a firewall involved. We're breaching the firewall to enunciate a fault or whatever, a condition. And so more than likely, at least for a lot of companies, they will use some sort of third-party device to safely bridge the firewall, something from a company like Sycamia or MB Connect or E1 or Tazibox, one of those guys, again, to allow the enunciation to happen safely through the firewall. So the same machine monitoring I was talking about, but for remote personnel, for a remote site, that's also capable with the OCS. And then if you want to kick your machine monitoring up another level, beyond just, are we, do we need material? Are we up? Are we down? That sort of thing. You can also use our product as a full-on OEE production monitor, where you are not only monitoring the health of the machine, but you're also logging things like uptime and downtime. And you're maintaining the statistics and the records and the logging for all of your OEE metrics, your availability, your quality, all those sorts of things. And we even sell, we have a solutions group that even sells a pre-packaged OCS in a panel that's pre-programmed as an OEE production monitor. So there is no Seascape programming required with this solution. You just walk up to the touchscreen and you can configure everything from the touchscreen. So OEE production monitoring is another big application for our products. IIoT edge device. So these days with the industrial Internet of Things, there are lots of great edge devices available out there. A lot of them are used to take maybe legacy PLCs or PLCs that are, have been installed years ago to get data from those PLCs and get them into a server or get them into the cloud, depending on the application. And, they may be using one of several different approaches to make that happen. An edge device typically has to be able to interface with equipment over plant type protocols, and then aggregate the data and report it over, an IoT type protocol, typically at least. And that's something our product can do very well. We support the Ethernet IP and Modbus TCP and some of the other most popular plant type networks for interfacing with plant floor type devices. And we support MQTT Sparkplug for pushing data to a broker for the purposes of a server or the cloud or what have you. So, and of course we can aggregate data, we can log it locally with our micro SD card, all those sorts of IoT type functions. You can use our product to do that. You don't necessarily have to get a dedicated IoT gateway. And oh, by the way, there's a full PLC built in there as well. If you want to also use the extra IO and the logic capability and all those sorts of things to do some level of control in your plant, you can also use it for that, of course. And then a couple more things I'll highlight real quick. Remote level monitoring, remote tank monitoring, that's a very popular application. Maybe you've got a tank farm, you want to just monitor the levels in the tank, set alarm levels, do enunciation whenever you approach certain levels, maybe connect to a wireless network, maybe a 900 megahertz local network or dedicated network, or maybe a campus-wide Wi-Fi network you want to tap into or something like that. So that's all capable with our products as well, with obviously the built-in I/O for connecting to just about any level sensor you could imagine. Or if it's a network-based or field bus-based level sensor, we could do that as well. And then one of the things that our controllers do very well is interface with VFDs. Now, a lot of times VFD interface is just part of a overall application, another application, but we support, all the typical Modbus is the most common low-cost protocol for interfacing with low-cost variable frequency drives. We also support other protocols as well. But interfacing with the drives both over a network or even through an I/O connection, 4 to 20 milliamp and digital I/O connections, we do that all really well, and we can communicate the drive protocols so that we can enunciate faults and those sorts of things. Another application I want to highlight is lighting control. We have a lighting division at Horner as well, industrial lighting division. And one of the things that we do extremely well in industrial lighting is we have inspection lighting technology that is unique in terms of the lighting part of the technology. So in most manufacturers of automobiles in the United States, not in every plant, but most manufacturers of automobiles in the United States, in one of their plants at least, they have a Horner inspection lighting system, which usually means Horner lighting technology and Horner automation technology, controlling it. So there's really specific requirements for inspecting paint, for instance, of a car body coming out of the paint room or what have you. And our lighting technology meets those requirements. And then, of course, our control technology works alongside it to, to complete the system, whether it means adjusting the color for an RGB type inspection system, or whether it be just adjusting intensity, for instance, of just a white LED system. And then HVAC is another area. Building automation is one of our biggest segments, industry segments, where we have a lot of success there in HVAC. And then the last slide I'll put up here is just push button and relay replacement. There still are systems out there that are just relays and push buttons. So our micro OCS is very inexpensive and has everything you need to replace some of those systems. And so I wanted to just kind of mention that here. So that's my rundown of the Horner controllers and, some of the areas where you can use them.
Well, I appreciate that too. And I just, for the audience, if you don't watch the Automation Morning Show, we've been covering all the most of the weekly seminars they have, webinars they have, and I believe they're all on demand, right? After they go live.
Absolutely right. That's one thing we do is we always, post every video, and so you don't have to watch it live. And as you would imagine, most of the views are on replay. Most of the views are on demand or on replay.
Yeah, and so if you want to know how Horner interfaces to X, whether it's a servo drive or something else, I think this past year I've seen them. They've done everything. They've interfaced almost everything under the sun. So they have an impressive library that, and again, we'll continue to cover it on the morning show, but definitely worth checking out. If you go to automate.news and click on any of the Horner, we list them under events, so you can sort by Horner or sort by events. If you click on any of them, you'll go to the page where I believe all of them are located, or we'll find a link to them. And if you're watching, you can see those links. It's hornerautomation.com. It's right on the screen there. You'll find them on YouTube and on LinkedIn as well. Before we go, Chuck, was there anything else you wanted to say to close out the episode?
No, not necessarily. Just that I'm really appreciative of the opportunity to, get in front of your audience and tell them a little bit about Horner. So I hope it hasn't been too much of a used car sale today. I try and do my best to give everybody the scoop without sounding like I'm selling them a 1983 Buick.
Well, I don't know what the audience thinks, but I think it was perfect. I mean, you answered my questions and you brought us through the entire, the meat of the line. I think anybody who, like me, knew nothing about Horner except that you guys have this great webinar series, I feel very comfortable. Like I could identify not only what your product does, but which one I would need for a certain application. And there's some really neat features in there that I think some of our audience may want to play with. Maybe they want to do some MQTT, and some of the other people's products are kind of expensive, or they want to do different multiple protocols, or there's definitely some things in there. Maybe they want a standalone system separate from their large system because they don't want to touch the large system because of all the different people involved in that. So they want to put in their own system. So I think hopefully now a message to the audience, if you do contact Chuck or anybody over at Horner, just let them know that you heard about it on the Automation Podcast so they know that their time today spent with us was well worth it. And we really appreciate when you guys do that and let the vendor know. We've had so many vendors call us and say, we just sold all these things because they heard about it on your show. So that really, keeps us going. Along with the shares and the likes, that kind of feedback just puts fuel in our tanks. So with that, Chuck, I really want to thank you for coming on the show today and really appreciate your time.
You bet. Thanks again.
Well, I hope you enjoyed that episode, and I want to thank Chuck for coming on the show and bringing us all up to speed on Horner Automation's products. I also want to thank our sponsor this week, theautomationschool.com. They covered our production costs so we could bring you this week's episode. If you know anybody looking for PLC, HMI, or SCADA training, please mention theautomationschool.com to it. Now, if you did enjoy this episode, please consider giving us a like, a sub, and a share. That is the fuel that keeps us on the air. When we see more and more people watching the shows, it just puts fuel in our tank to get out there and reach out to more and more vendors. That can be quite time consuming because not everybody you talk to wants to come on the show. So we really appreciate when you guys give us that positive feedback and let us know we're doing a good job. And I also wanted to mention that if you're a vendor and you want to come on the show, just contact me. You can do so on LinkedIn or use the contact link over at Insights in Automation. Now, for those of you who would like to follow me or maybe submit technical questions for me to answer, you can do so over at our community at automation.locals.com. We had another 100 people sign up over the holidays, and I really want to appreciate everybody who's following us for free or joins up. I think it's $2 a month to become a member of the community. So I want to thank you all for doing that, and I really appreciate you guys over there. And with that, that's the end of this week's show. I want to wish you all a courageous, fearless, and awesome week. And until next time, my friends, peace.